The cotangent ratio is the adjacent side divided by the opposite. Here we've got a triangle with a right angle and an angle of 27 degrees. What is the cotangent of 27 degrees? So the adjacent side is 7.5 and the opposite is 3.8. .97. We're going to use the cotangent ratio to solve for side B, and we're going to use Desmos to calculate the cotangent ratios. So if we're solving for B, and we're going to use this 3 side as well, we can use the angle of 69.3. And then we have the adjacent side over the opposite. So to evaluate the expression, make sure that we're in degree mode. Then we can type in and we get a value of 7.94. We also could have used this angle and it would have been slightly less steps to arrive at the same number. So we can solve again using the tangent ratio this time, and we could use the same angle. And this time it's b over 3. That's the tangent ratio. And we see we're getting the same result. So now we're going to look at trigonometric ratios for negative angles. Our definition for the sine of theta is y divided by r. Y being the y coordinate of this point. In this case, negative 0.76 with this angle of negative 50. And so if we take that negative number and divide it by the positive 1, we're going to get a negative ratio. And we can see from the graph that when we go into the negatives, we're getting negative y values. Another pattern that we can see is that if we look at 0 and we go up 10 degrees or down 10 degrees, these two y values are the same except for their sign. And these two and these two. And so there's a symmetry at 0 degrees on either side of it. So that's a pattern. And so if we also take a look at the cosine ratio, we define that as x over r. So if this were our diagram, x is 0.643 and r is 1. That is a positive value. And so we look at this table of values from negative 90 to positive 90. All of the cosine ratios are positive. If we look at the graph, we see a bunch of positive y values from negative 90 to positive 90. So, if we know the cosine of 16 degrees is 0.9613, we know that the cosine of negative 16 degrees is also that value because of this symmetry. Suppose the cosine of an angle is 0.3. Solve for the angle A. Well, using our calculator, we get 72.5 degrees. So the cosine of A is 0.3. We take cos inverse of 0.3 and we get 72.5 degrees, which is somewhere around here. Somewhere around here on our graph. But there's another angle right over here at negative 72.5 that has the same cosine ratio. And so if we're looking for a solution between negative 90 and positive 90, there are two possibilities. Positive 72.5 degrees and negative 72.5 degrees. Okay, looking at the sine ratio, suppose we know the sine of 31 degrees is approximately 0.5. Then that would mean that the sine of negative 31 degrees is equal to the negative of that quantity.